So hello and welcome to another video from sickmaths.co.uk where you can find lots of free maths videos. This one's for the M1 Mechanics 1 module in the A-level maths for the Edexcel syllabus, and it's about equilibrium. So equilibrium just means when the forces are all balanced, so all these forces are all balanced so that the particle in the middle is not moving. So since we're writing all these forces in vector form, I'm going to work out the force X, which is missing, also in vector form, and I can see it's going in that direction and that direction. Those are the two components, the horizontal and the vertical components. So I'm going to write minus A and minus B because it's both going in the negative horizontal direction and the negative vertical direction. So now, since the forces are balanced, that means the 10 Newton force going in the right direction is balanced with the 3 Newton force going in the left, as well as the A Newton's force going to the left as well. So that means 10 is equal to 3 plus A. That force plus that force balances with that force. So 10 equals 3 plus A, therefore A must be 7 because 3 plus 7 equals 10. So that means A equals 7. We worked out one part of the one of the components of the X Newton's force. And what else? We need to work out the vertical component, so let's resolve vertically, and we can see this force, this is the only vertical component or vertical force going upwards. 4 newtons in the J direction is balanced with the B newtons going negatively in the J direction also. So basically 4 is balancing with the B, so the B equals 4. There's no vertical component here, is there? There's only 10 I newtons but no J newtons from this force. So we've got that. So basically A equals 7 and B equals 4. So you write X equals minus 7I minus 4J because we had minus A and minus B there. So that's that. Let's look at example 2. We've got a particle hanging from two different strings. Obviously you've got two different tensions because you've got two different strings. If you had one string, you would have one tension, even if, say, the string was threaded through the particle or something. So that tension would be the same as that tension. But they're two different strings, so two different tensions. They're hanging off a ceiling. As you can see, it's they're hanging at an angle of 30 degrees and 40 degrees from the ceiling, and you've got this mass of 5 kilograms, which is creating a weight of 5 G newtons. Okay, what is G? G is acceleration due to gravity, which is 9.8, and the way you work out a force or the weight of a particle is you do the mass times the gravitational force on it. So that's that. So resolving the first forces horizontally, you get the horizontal component of T1 balances with the horizontal component of T2. So what is the horizontal component of T1? It's going in that direction, so you do T1 cos 30. So how do I know it's cos 30? Because we're going through the angle. If you don't know about this trick of going through the angle, go through my trigonometry video for mechanics, and I'll explain the little tricks about how to do this all very quickly. So you go through the angle, which gives you cos. So T1 cos 30 is balancing with T2 cos 30, which because we're going through the angle as well to get to the horizontal component there. So T2 cos 40, is equal to T1 cos 30, as it says here. And if you rearrange it, because we know we're going to make we need to make T1 or T2 the subject, so we can stick it into the other equation which we get when we resolve vertically. So I'm going to make T1 the subject. I could have made T2 the subject, but I'm going for T1. So making T1 the subject simply means move the cos 30 to the other side. So I get T1 equals T2 cos 40 divided by cos 30. So that is my equation 1. And now resolving vertically, I have to look at all the forces in the vertical direction. This 5 G newtons balances with the vertical components of T2 and T1. So let's work out the vertical components of T1 first of all. The vertical component of T1 is going upwards like that. That's going away from this angle, which is T1 sine 30. Again, look at the trigonometry video if you don't understand how I did that. The trigonometry for mechanics video on the SICK Maths website. In the A-level section, of course. So T1 sine 30 plus T2 sine 40 should balance with the 5g newtons going downwards. So that's like this: T1 sine 30 plus the T2 sine 40 is equal to 5g newtons. I didn't write newtons ever in this, have I? I should have wrote newtons at the end maybe, but I don't tend to write newtons unless they ask me to. So anyway, so you've got that. These two forces are balancing, and now I stick this T1, I replace T1 with all this stuff, so you get that. So instead of T1 sine 30, I've got T2 cos 40 divided by cos 30 times sine 30 plus the usual stuff from here is equal to 5g newtons still, and rearranging to make T2 the subject this time so I can work out what T2 is. Basically, do you understand that this is simultaneous by substitution? So we're substituting, work out one of them, basically T2 in this case. Rearranging is very easy because T2 is a common factor here and there. So basically take T2 out of the brackets, and you got T2 times all of this. So T2 times cos 40 sine 30 over cos 30, that's that, plus sine 40 there, okay, and then take it all out as a factor, divide it 5g by all of that stuff, and you get T2 equals 5g divided by all of that stuff, yeah? So cos 40 divided by cos 30 times sine 30, which is this bit, plus the sine 40 bit, which is this bit. So you get T2 equals 32.47 by working out all of that. Once you know what T2 is, you can work out T1, because T1 is equal to T2 times cos 40 divided by cos 30. So you do that, T1 equals that times that divided by that, which gives you T1, which is 28.73 newtons. So that's that. As you can see, I substituted T2 into this one as I just said there. So anyway, so that's done, and we've worked out forces T1 and T2.